6.3, we are still looking within triangles, but now we are looking at medians and altitudes. Unlike angle bisectors and perpendicular bisectors, medians and altitudes exist only within the triangle, so they are defined by the triangle. First, we'll look at a median. A median is a segment from the vertex to the midpoint of the opposite side. We can draw 3 medians in a triangle. Sometimes you'll have 1, sometimes you'll have all 3. If I draw all 3 from each vertex to each midpoint of the opposite side, they are all going to meet at one point, which is known as the centroid. Right? The centroid is the point of concurrency of your 3 medians. So we have our centroid theorem. The centroid theorem says the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the opposite side. Okay? So each one of those lines, right, they go through the point. Unlike our other problems, this is one line. So A, P, and E are all on the same line, AE. B, P, and F are all on the same line, BF. And D, P, and C are all on the same line, DC. Have the whole line and 2/3 of it. So AP is 2/3 of AE. BP is 2/3 of BF. And CP is 2/3 of CD. That means the other part will be 1/3. So PE is 1/3 of AE. PF is 1/3 of BF. And PD is 1/3 of CD. There's also a relationship between those. So you can use 2/3 and 1/3 and the full, and you can also use the reciprocals of 3/2 and 3 to solve all of these. But the relationship a lot of times is easier than that to look at. So if I look at AE and say that AE is 12, that is the whole line. AP is 2/3 of that. Right? I'll come back to that in a second. PE is 1/3 of that. That is easier to find. I'm just dividing by 3. So PE is 4. I now have 2 ways to find AP. I can do the 2/3 or I can subtract. 12 minus 4. So AP is 8. The relationship between those numbers, because of the 2/3 and 1/3, is always going to be exactly like that relationship is. It won't always be those numbers. But we are going to use numbers that are divisible by 3, which makes our life easier. So 12, I divide that by 3, I get 4. Double that, I get 8. That relationship is always there. So if I would give you that BP, right, which is the 2/3 part, I would give you that this is 4. To find PF, the 1/3 part, I just cut in half. To get the whole thing, I can add those 2 together is probably the easiest thing to do, or I can multiply PF by 3. either way, I get 6. So that relationship is always there. If I start with the smallest one, in the red example there, PF is 2. To get the middle one, I double it and get 4. To get the full one, I multiply it by 3 and get 6. So in example 1, they tell me GM is 6. GM is the middle number. So I cut that in half to get ML, and this is 3. Add those together, GL is 9. B gives me the same thing with FM. MK is the smaller part, so I cut FM in half and get 5. Add those together, FK is 15. The only difficult part of this would be if I set up an equation, like they have in example 2. The key thing is paying attention to which part is smaller, which part is bigger, and make sure you're doing the appropriate thing. Right? FK is the whole thing. MK is the smallest part. So if I'm starting with MK, I want that to get bigger. So to make that get bigger, I multiply that by 3. And that would be my equation. You could also set this up and reduce the larger part. So I can do 1/3 of 6x plus 9 equals 5x. Make sure you're distributing the 1/3 in that case. It will get you the same answer. Generally, I don't like that way as much because then if it doesn't divide by 3, you have a fraction or a decimal. In this case, it would work out nice. I'd have 2x plus 3 equals 5x. And I can solve that easily. Sometimes that is better because you have smaller numbers. But if I look on the other side, 3 times 5 is 15. That is not getting me that big of a number. So I can do 15x equals 6x plus 9. Subtract the 6x from both sides. And I have 9x equals 9, and x is 1. Our last thing here is the altitude. The altitude is the perpendicular segment from the vertex to the opposite side or line that contains the opposite side. You probably think of this normally as the height. If I have my triangle, that red line that hits at 90 degrees would be an altitude. However, I can draw an altitude from each side. So those 2 blue lines are also altitudes. The point at which they meet is known as the orthocenter. From everything I've been able to find, the orthocenter is our least useful of our centers because we do no math with it. As far as I can tell, it serves no purpose. All right, but it is where our altitudes meet. So one thing you'll have to do with these is know the rules and how they match up and what they give me and what I would have. So when we flip this over, example 3, all right, is saying if they give me just this information, which thing do I have? So if I know YW and XZ are perpendicular, and that's all I know, that is an altitude. It hits at 90 degrees and is therefore an altitude. If XW and ZW are equal, it is a median. If it does both of those things, it is a perpendicular bisector. Perpendicular bisector that goes through the vertex is also an altitude and a median. Okay? If my triangles are congruent in this picture, I would have all four of my things. I would have the 90 degrees, I would have the perpendicular, I would have the segment being bisected, so I'd have the altitude, median, and perpendicular bisector. I would also have the angle bisected. Example 4 is probably harder than what we get into as far as doing a proof, but it is showing a proof that the altitude in an isosceles triangle is the median. All right, so I have my given information. Because they tell me it's isosceles, I know that two of my sides are congruent, AB and BC. That's number 2. Because it is an altitude, I know that this angle is 90 degrees. I know that those things are perpendicular. That's what I know based on an altitude. Right? That also gives me 4. Because it's perpendicular, it's 90. Anytime I see these, you should automatically look for the line that they share, which is my reflexive property. BD is congruent to BD. So now I have congruent triangles based on hypotenuse leg, based on CPCTC, corresponding parts of congruent triangles are congruent. I know that AD and DC are equal. That's the bottom part here. Okay. That is what gives me a median. So if that is an isosceles triangle with an altitude, it has to also be the median. If I'm looking for the coordinates of my centroid, right? This is looking for the midpoint, the vertex to the midpoint of my opposite side. So draw things that are easy. In the first one, it is easy to come from here, B, find where my middle is, right here, and draw that line down. So I have one of them. Then I need to find another one. They're all going to meet in the same point. You can find all 3, but if I find 2 correctly, that is going to be my point. So if I look at my slope, as I'm coming up here, I come up 1, 2, 3, 4, 5, 6, 7, 8, 9, and I come over 1, 2, 3. If I do half of that, I'm going to come to a point on this line. That is my midpoint. So this point right here is where my centroid would be. I'm going to switch to the next page and talk about the orthocenter and finding that. That is our lines that hit at 90 degrees. Some of these points don't have to be in the triangle. Both examples here, one is on, one is outside. The first one is on. This is a 90-degree triangle. This angle right here is 90 degrees. So BC and BA are already drawn as altitudes. The other altitude would come this way. So point B is my orthocenter because it's a right triangle. That's always going to be true on a right triangle. Okay. If I look at QR, right, where that is going to hit at 9, or where the point line from P is going to hit that at 90 degrees, it's not going to be anywhere on QR. It's going to be as I extend this out, this line is going to come down and hit at 90 degrees there. Okay. Because of that, my orthocenter would be outside. Right. and I'm looking at this line here that extends down, and wherever that hits one of the other ones. So if you're looking for something like this, my suggestion for what we're doing in this class is estimate where it would hit one of the other lines at 90 degrees. So for me, I think this would hit at 90 about there. I come down that way. That is approximately where my ortho center is. Right? And some of the 90s will be easy, some of them will not. I would want to see that you're looking at the concept. So I want to see that you know this should be 90. So marking that and showing me that you're saying that is 90 is what I am looking for what we're doing in this class, if I'm asking you to draw